did before. So really, it's not too long of notes today. So let's start with some bacteria here. You have 25 bacteria in a petri dish, and the number of bacteria doubles every 4 hours. Okay? So you double every 4 hours. So let's fill in the first 3 parts of this table, and then we'll figure out to use those blank spots. So if you start with 25 bacteria, after 4 hours, how many bacteria should there be? 50. All right. And then after 8 hours, there would be 100, and then 200. Okay. So if you double, we're doubling every 4 hours. Now, we want to know how many bacteria will there be after 1 hour and after 2 hours. So this part's a little bit different because we're doubling every 4, not every hour. So I'm actually going to kind of combine B and C together into like one question here. Let's come up with an equation for how we could find 1 hour and 2 hours. Okay, so let's start by thinking, all right, I want the number of bacteria, so I'm going to use N for number because I can. If I'm writing an exponential model here, how many bacteria do you start with? 25. So that part stays the same. 25, and how is the number of bacteria growing? It's doubling. So we're multiplying by 2. Like I said, I'm combining B and C into the same question. It's doubling. Now, it's doubling how often? Every 4 hours. So if I put just T for time in my exponent, does that cover it? No, because the T here is every 4. So what do I have to do, Jamie? Divide by 4. Why would I divide by 4? Because it's every 4 hours. Or Rachel said it. I gave Jamie credit for all Rachel's work. You divide by 4 because you're going every 4 hours. So if I want to find 1 hour, and I have to put 1 in for T, that's 1/4 of the amount of time that it's doubling. So that's your model. So now let's use this model. Type this in here. 25 times 2 to the 1/4 power. Figure out how many bacteria there are after 1 hour. Why? Because it's every 4 hours, but you want to find 1 hour. It doubles every 4, so after 1 hour, that's 1/4 of that amount of time. So how many bacteria are there after 1 hour? 29.73. So you have a decimal number of bacteria. Now let's find after 2 hours. So you would do 25 times 2 to the 2/4 power. And how many bacteria would there be after 2 hours? 35, 40, 36. Yeah, we'll do 355. We'll go 3 decimal places. Or 36 is good. I'm not worried about it. Okay, does that model make sense? Because that was a little different than what we've done in the past. Okay. Now, what we're going to do with that model, again, I'm kind of adjusting B, C, and D here. What we're going to do with that model is now we're going to put it into our calculator to answer a question. But before we put it into our calculator, there's our model. I just put it up there so we can reference it. We want to know how many bacteria there are. I guess we're not using the calculator yet. I lied. How many bacteria are there after 24 hours? So where would the 24 go into this function? For T. All right, so we would type in the number of bacteria is 25 times 2 to the 24/4. Now, if you wanted to save yourself some time typing the exponent, what would the exponent be? 6. So if you wanted to, you could type into your calculator 25 times 2 to the 6. You don't have to, but if you didn't feel like writing 24/4, yes, what question? You guys? Okay. How much? What'd you say, Bobby? 1,000. Was it not Bobby or Reese? Apparently I don't know if he's talking anymore. 1,600 bacteria. Right. It's going better than last period so far, so you know. Things are looking up. So 1,600 bacteria. Now here's where we need our calculator. It's going to take a whole day, 24 hours, to get 1,600 bacteria. We want to know, we're going to use our graphing calculator, we'll set it up in a second. Ultimately, we want to know how long until there are 5,000 bacteria on the petri dish. So we're going to put this in our calculator and we're going to set the window. That's what this part F is looking for. We want to know what should our X window setting be So how far left and right and how far up and down for the y's. Well, what does the x-axis measure here? What is your x? That's like your t. What is that measure? Your hours. All right, so the x-axis is measuring your hours. And what do you think you want to make your x min and your x max? What do you think? There's no right or wrong, just, yeah, okay, we'll start at 0. And how far out do you think we want to go? 100? Sure. So we'll go, x max will be out to 100. And then what does the y-axis represent in this problem? The number of bacteria. Okay. And we also need our y minimum and our y maximum. Now, where should I start with my y minimum? 25. Yeah, we can do 25 if you wanted to. That's your starting value, so we can start at 25. How high up should we go? I want to know, ultimately, if I look ahead, I want to know when we get to 5,000. So at least 5,000, right? You want to go higher than that, lower than that?
No, 5,000.
5,000 even, okay. We'll go just to 5,000. We'll go 25 to 5,000. That's fine. So let's put this into our calculator. We're going to type in our formula, 25 times 2 to the x over 4 pounds. And when you go to your window, you can set it, what do we say, 0 to 100. You can make the scale whatever your heart desires. So I'm going to make my scale go by 10s. You can go by 1s, you can go by 5s, you can go by 25s. It doesn't bother me. And we're going 25 to 5,000. I'll make my scale go by. I'll make my graph. Your picture should look something like that. Now, quick review before we move on. When you look at this picture, is this exponential growth or decay? Growth. How can you tell by looking at the picture that it's growth? It's going up. How can you tell by looking at the equation that it's exponential growth? It's not what? Not 0. It's 1. Yeah, we look at the growth right here. That number is bigger than 1, so that it's increasing. Can it ever be a negative growth rate? No, it has to be positive. Yes, teacher.
Oh, wait, what was the word?
I think we had 5,000. Yeah. All right. So now when I look at this picture, here's what we want to do. It says here, use the table in your calculator to find between what 2 hours you get to 5,000 bacteria. So let's go over to our table, and I want you to scroll through for a minute here. And I want you to see, where does the y-axis get to 5,000? So scroll. And I think I hit it too many times. It's down with me. There we go. It gets pretty big pretty fast. Do you see where you get to 5,000 between what 2 numbers? Between 30 and 31, yeah. Oh, I used to be able to write on this. That's sad. Oh well. Well, between 30 and 31 here, I go from 4,500 to 5,300. So between 30 and 31 hours. Okay, what's confusing?
Oh, wait, never mind. I thought the 1,000 were 100s.
Are you having a day too, KJ?
Yeah.
It's okay. Should have seen me 7th period. I was not sure what I was talking about. It's special. Alright. Now, we estimated. This is where we got last time's model, right? We got to this far and we said, okay, we can estimate between 30 and 31. Well, that's all we can do. We're done. Well, maybe fortunately or unfortunately, depending on what you like solving with logarithms, we can actually solve this now. We can find down to the decimal how many hours it's going to take. So let's set up an equation here. All right, we start with 25. This is just the model that we wrote already, so I'm just rewriting it. 25 times 2 to the t over 4 power. We want to know when exactly we get to 5,000 bacteria. So what should I set this equation equal to? 5,000. Now we are going to solve for t. We have the tools now to figure that out. So what would you do first here? What would you do on your quiz today if you saw this? Divide by 25. So we're going to divide both sides by 25. And we'll get 2 to the t over 4 power equals, what's 5,000 divided by 25?
200.
200 is right. Now, what do we do to get that exponent out of the exponent? Throw a log at it. Now, when I throw a log at it, where does the exponent go? In front. So I have t over 4 times log of 2 equals log of 200. What do you want to deal with next? The log. Always deal with the log next. So we'll divide by log of 2. If you're tired of writing logs now, I'm sorry, but wait till the next couple days. All right, so I'm going to save myself some writing just because I can. After I divide by log of 2, what do I have to do with that 4? Multiply by 4. So you're going to take your calculator and find for me log of 200 divided by log of 2. Enter times 4. And it'll tell you exactly, down to 3 decimal places, how long it's going to take. What do you get? 30.575. So it is right in between 30 and 31, 30 and a half hours. So we have one more here. Similar modeling problem if you want to flip your paper over. So we solved this one. The next one's going to be pretty easy to solve here too. It's setting up the model I want to make sure we remember. So for a particular person, you get a dosing regimen of a drug. So like ibuprofen type thing. Right? They give you, if you ever read the bottle, it says take a medicine this much every 4 hours or 6 hours. It says it reaches a peak level of 300 milligrams in your bloodstream. And then the drug is eliminated from your bloodstream, so it wears out at 20% each hour, right? That's why when you take ibuprofen in the morning, when you have a headache or your muscles hurt or whatever, it wears off after a while. It leaves your blood and you need to take more. So we're going to skip A for a second. Let's jump down to B, and then we'll go back and fill in our table. If I have to write an equation, so it says use F after T hours. So we'll do F equals, how much medication in your blood do you start with? 300. It starts with a level of 300, and it's decreasing. It's decreasing by 20%. Does anyone remember what will go in the parentheses? Not 0.2, 0.8. I get the 0.8 because remember, percent decrease, you take 1 minus the percentage that you're decreasing by. So 80% is in your parentheses to the t power, right? Certain number of hours. Now, you can take that, and I would put it into your calculator, into the table. It would save you some time, and then copy the values from your table. So let's type 300 times 0.8 to the t into the y equals. And then when you are ready, you can go to the table, and then I would copy, you'll have to scroll back, but you can copy all those numbers into your table. So take a minute there. Once you do that, I will copy them onto the board here. Let's see. So reviewing some calculator skills, we haven't done this a little bit here. Doesn't hurt. Now, is this graph increasing or decreasing when you make the actual picture graph? Why is it decreasing? How can you tell from the equation? Yeah, the growth rate here, 0.08, is less than 1. So you know that when you make your graph, it's going to be going down. Okay. Questions on that part so far? All right. So when I graph this, I have that equation at the top again. I'm going to make the picture. Now, we already put it into our calculator, so we just have to adjust our window. So the x-axis is still measuring time. Typically, the x is going to measure time. What do you want our x scale to be? I'll write it as an inequality this time. From 0 to what? Where do you want us to start? Doesn't matter to me. Just pick something. 7. All right, we can do 7. We'll go from 0 to 7. Make our graph. And then I want the y-axis. Now, when I look at the y-axis, that is the amount of the medicine in your blood. We have to figure out a maximum and a minimum here. So how low do you think we can get our medicine to go? Well, that's how high. That's what we start with, right? So our highest amount is 300. That's where we start. Can I go any lower than 0 with the medicine? No. So we'll go from 0 to 300. That will be your window setting. So let's take a minute and then recalculate here. Re-put in our window setting. We already typed it into y equals, so we just have to type. Here, we'll go 0 to 7. And then 0 to 300. Look at that. Is that decreasing like we said? Did you mess up, Jamie?
That's the wrong numbers on everything.
Okay. Did you put them in for your table wrong too? Or
got
the
it.
window? Okay.
I put I'm kind of confused. My minimum is like 300, like for the windows, but you just went to the menu. But you just went to the menu and then went to windows, but then
Okay, so we're going to yeah, if I hit the first one, this is window setting. Yeah, you're right. Windows 2, and then the first one is window setting. Yeah, no, you're good. Good, I'm glad I could help. It took me a couple years to figure out the inside, but now that I know it, oh. All right. So I have this picture. Now here's what the question is asking us this time. It says, use the table, or you can use your the graph, I don't care. How long will it take to be less than 10 millimeters of medicine in your blood? So I would pop over to the table. Yes, Steve. You got it? What's the answer? 16 hours. You guys agree? If you scroll through the table here, do we need to see it? You're good. Okay, 16 hours. Good. Now, again, we know it's about 16 hours, but we need to find it exactly because, you know, what fun is it just stopping here? Right? Right? This is the most fun part of your day, right? Solving exponentials? I thought so. We're going to write an equation. So we want to take the amount we started with, which was 300 times 0.8 to the t. What should I set this equation equal to this time to find the time where it gets to 10? To 10. Okay. And I need to solve this equation. So just like the last one, I'm going to start by dividing by 300. Okay. Now what is 10 over 300? You put that in your calculator. What does it give you?
a third.
Not 1/3. 1/30th. I would leave it as 1/30 because the decimal is like 0.03 repeating, and you can't. We want exact numbers, so we'll leave it as 1/30. And then, what kind of log am I going to throw at this? The regular. The what? The common log. So when I take the common log, the t comes in front. And I'm going to take the common log of both sides. And I forgot to ask Lauren before she turned in a quiz if she took the log of both sides. You did.
Are you sure about that?
All right. Last step is you divide by the log. This one's easier. So I want you to put that into your calculator if you haven't already. And tell me, 2 3 decimal places, how long is it going to take for this medicine to wear out of your system? 15 point what? 252 or 42? Thank you. Good. So about a little less than 16, but we were right there. About 15.242. Good? You guys feel okay with this? I know we didn't really do it, the solving is not harder. However, when you flip to your practice, I'm not going to go through all the practice with you, but I am going to start with one of them. So let's look at the practice here. So we're going to practice on the next page. I'm not going to go over number 1 because in a second when you start working, I'll flash like the main answers up here. I want to look at number 2 with you really quick because While the setting up isn't that hard, it's the second part that's a little bit different. So let's talk about the population of fruit flies here. Population of fruit flies starts with 50 and it's increasing by 8%. So I'm just going to set it up for you and you can finish solving. If I write an equation for the population of fruit flies, what equation would you write here? Y equals, we're on number 2 of the homework. I'll set this up for you. 50. Now if you're increasing by 8%, what would go into parentheses? 1.08 to the x. Okay, that part is easy. The next part is not hard, but we haven't had the wording like this before in B. It says write an equation to determine when, now when is time. What variable is measuring time here? X is. So we're going to solve for x here. Okay, that helps us in a minute. When will the population of fruit flies triple? Okay. Then solve the equation. Now, how many fruit flies did you start with? 50. What's the triple of 50? 150. So my goal is to figure out how long until there are 150 fruit flies. Where do you think the 150 should go? For y. Y is the population. We used y, but you could use t. So you need to set up the equation here. 150 equals 50 times 1.08 to the x. And when you solve it, you'll find the value of x, which is the... So finish that one up. There's some good ones here. I'll leave the answers for the solving part on the board. You can check as you go. Otherwise, if you need some help, just let me